In this lesson, we're going to review how to reduce radicals. So you will want a pencil and a paper out to do this. So before we see a couple of examples, I want you to recall what perfect squares are. So if you remember, perfect squares are the result when you multiply a number by itself. So for example, if I was to multiply 2 times 2, I would get 4. So 4 is a perfect square because that's the result when you multiply 2 times 2. 9 is a perfect square because that's 3 times 3. 16 is a perfect square because that's 4 times 4. 25 is 5 times 5. So all these numbers in blue, these are all the perfect squares that I'm circling. So because it's the result of multiplying a number by itself. So these numbers have a special property, is that when we take the square root, so the square root looks like this symbol. When we take the square root of a perfect square, so let's take 4 for example, the square root of 4, that's going to give me 2, because 2 times 2 gives me 4. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, because when I multiply 4 by itself, I get 16. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7, and I'll just do a couple more. The square root of 64 is 8. The square root of 81 is 9, and we'll do the square root of 100 is 10. So when we reduce radicals, we're looking for these perfect squares, because notice we can take the square root of perfect squares, but when we work with other numbers that aren't perfect squares, it won't be so easy to take the square root. So let's look at an example. So I put those square roots on this page so that you have it. So the square roots that we know. So in this first example, so reduce to radical, so it's square root of 75. So notice the square root of 75, if you look at your list, would be in between 8 and 9. So in between the square root of 64 and the square root of 81. It'd be somewhere in between there. So I'm going to start with 64. Because that's less than 70, that's just less than 75. So I'm going to start there, and I'm going to say 64, that would go into 75, but it doesn't go in there evenly, so I'm not going to divide by 64. I could check 49, it does not go in there evenly. 75 divided by 36, again, it would go in there, but not evenly. And then that leads me to 25. So 25 goes into 75 evenly. So I'm going to rewrite this as 25 times 3. So the reason why I chose 25 as opposed to some other number is because 25 goes in there evenly, and it's the largest square number that goes into 75. So I can rewrite 75 as a square root of 25 times 3. So that 25 is my square number. So it's okay to write it this way because we're not changing the problem. We're leaving it as 25 times 3. So when we reduce radicals, there's a nice property that says if I have a product of two numbers underneath the same radical, I can split them up. So in other words, I could rewrite this as a square root of 25 times the square root of 3. So if I have a product underneath a radical, I could split it up into two separate radicals. So why does that help me? Well, it helps me because we know what the square root of 25 is. The square root of 25 is 5. And we don't know the square root of 3. The square root of 3 would be an irrational number, meaning the number is a decimal that keeps on going on and on forever. So we're going to write our answer as 5 times the square root of 3. When you work in MathXL, this is the way that you're going to want to put your answer in there. You cannot put decimals in MathXL for this assignment. You will need to write it in exact form. So you will need to write it with a radical sign. So decimals are not acceptable. So let's look at another example. The square root of 44. So I'm going to look at my list again. The square root of 44, somewhere in between 6 and 7. So I'll just start off the one that's exactly lower than that. So because obviously 49 would be larger than 44. So I'm going to start with 36. 36 goes into 44, but not evenly, so I'm not going to choose that one. 25 would go into 44, but again, it doesn't go in there evenly. I would have some type of decimal. 16 would go into 44, but again, I wouldn't go in there evenly. So again, I would end up with a decimal, so I'm not going to choose 16. 9 would go into 44, but it doesn't go in there evenly, so I'm not going to choose 9. So the only one that's going to work is the 4. So I'm going to break up 44 using 4 times 11. And as you get more practice with this, you'll get pretty good at determining which of the perfect squares goes into that number. So 4 times 11, so I can rewrite this as 4 times 11 underneath the square root, and then split it up as 4, square root of 4 times the square root of 11. Square root of 4 is 2. Square root of 11, that's an irrational number. We don't know what the square root of 11 is, so we're just going to write our answer as 2 square root of 11. So example 3, reduce the radical. So we have square root of 24. Again, where would this be in between? This would be in between 16 and 25. And you might already know which one divides in there nicely, but just so that we can see the process, if I start at the one that's lower than it, so if I start at 16, 16 would go into 24, not evenly, because there would be some type of remainder there. So I'm not going to choose the square root of 16. Again, 9 into 24, that wouldn't go in there evenly, so I'm not going to choose 9 either. So that means I'm going to leave it in there. I'm going to use the square root of 4, because 4 goes into 24 evenly. If I divide 24 by 4, I get 6. So I'm going to rewrite this as 4 times 6. Now I can rewrite my radical, square root of 4 times 6. And remember, that special product property of radical says I can split this up as the square root of 4 times the square root of 6, because I have a product underneath the radical. So we know what the square root of 4 is. The square root of 4 is 2, but we don't know the square root of 6. So we're just going to leave it as square root of 6. So remember, 6 is what we call an irrational number. That's a number that the decimal keeps on going on forever and ever. So these next few examples are going to have a number in front of the radical, and that's fine. We can still reduce the radical. We're just going to reduce the number that's inside. So here we have square root of 80. So I'm going to work through this one a little bit quicker. That number inside, we could break it up. So the largest number here that's going to go into 80 would be 16. So this would get you 16 times 5. You could just check the numbers in your list. So 16 times 5 would be the way to split up the square root of 80. So I'm going to rewrite it as 3 square root of 16 times 5. But remember, that product property says I could rewrite this as 3 times the square root of 16 times the square root of 5. We know the square root of 16 is 4, so this would be 3 times 4 square root of 5. 3 times 4 is 12, square root of 5. So our answer here is 12 square root of 5. Whoops. So let's look at another example. Similar to this one, 8 square root of 40. Again, if you were to check, square root of 40 would be in between the square root of 36 and the square root of 49. So you could check all those radicals that are less than the square root of 49. But I'm going to just show you that this is going to be, we're going to use the square root of 4 to reduce this. So the square root of 40, we could break that up as 4 times 10. So the more you practice with this, the better you'll get at determining which is the highest square number that will go into the radical. And even if you don't pick the highest, you'll still get a right answer. It just might take a little bit more work. So 8 square root of 40, I could write this as 8 times the square root of 4 times 10. So we remember that product property says I can split this up as 8 times the square root of 4 times the square root of 10. So just break up the radical. We know the square root of 4 is 2, so it's be 8 times 2 times the square root of 10. 8 times 2 is 16, square root of 10. So this would be 16 square root of 10. I have two more examples for you to try. So 2 square root of 6. The square root of 6, if you notice, would be somewhere in between the square root of 4 and the square root of 9. There's not really a way to break up the 6. It's an even number, so you would hope that there was a way to break up the square root of 6, but there's not, and that's okay. So we're just going to leave this 2 square root of 6. Sometimes you won't be able to reduce the radical, and that's fine. So you'll just rewrite it as 2 square root of 6. I want to do one more example with you. Example 7, so reduce the radical. So negative square root of 108. So again, the negative out front, we'll take care of that last, but I want us to simplify. I want us to split up 108 using perfect squares. So again, square root of 108 would be somewhere in between square root of 100 and square root of 121. It would be somewhere in between there. So what I want you to do is I want you to check the perfect squares that I'm about to circle. Check those perfect squares. Which one is the highest one that goes into 108? So use your calculator. Tell me what I want you to determine which is the largest one that goes into 108. So pause the video and give that a try. So hopefully you gave that a try and you realize that 108 is divisible by 36. That's the largest square number that's going to go into 108 is 36. So it's going to be 36 times 3. So if you divided 108 by 36, you'd get 3. So I'm going to rewrite this as negative square root of 36 times 3. So again, that product property says I could rewrite this as negative square root of 36 times the square root of 3. Square root of 36, that's 6. So this would be negative 6 square root of 3. So that would be my answer. So I want to show you this one under the assumption. Let's say that you didn't choose 36. 108 is divisible by either 9 or 4 as well. So let's say you accidentally chose, 4. So what you would do is you would say, okay, well, 108 divided by 4 is 27. So I'd write that as 4 times 27. And then underneath the radical, 4 times 27. Split it up just like you would. So this would be square root of 4 times square root of 27. Well, we know square root of 4 is 2, so this would be negative 2 square root of 27. And then let's say you put this in MathXL, it would say wrong answer. So if that's the case, then you're going to want to look at, did I fully simplify what's underneath the radical? So let's look at 27. Is 27 divisible by one of my square numbers? So it's not divisible evenly by 4, but it is divisible by 9. So I'm going to split up 27 using 9. So 27 divided by 9 is 3. And now I could rewrite this as negative 2 times the square root of 9 times 3. And then negative 2, this would be square root of 9 times the square root of 3. Well, we know the square root of 9. The square root of 9 is 3. So negative 2 times 3 times the square root of 3. And this would be negative 6 square root of 3. Now, when you check your radical, notice I can't reduce the square root of 3 any further. So then I know I'm done. So just make sure you're on the lookout. Just make sure that what's underneath your radical is fully simplified. So after viewing this, you should be able to start the reducing radicals assignment in MathXL. It's called Reducing Radicals Parts 1 and 2. You should be able to do the first half of that assignment, numbers 1 through 9.